Let's try solving the volume of the solid using the washer method and the shell method. Let V be the volume of the solid obtained by rotating about the y-axis, the region bounded by y is equal to the square root of x and y is equal to x squared. If we graph the problem, it will look like this. This is the function y is equal to x squared, and this is y is equal to the square root of x. So in washer method, this will be the outer radius and this will be the inner radius. While in the shell method, this will be the height will be top function minus bottom function. So the height will be square root of x minus x squared. Let's do the washer method first. So if it is rotating in y-axis, we will be using this formula. V is equal to the integral from c to d pi times square of the quantity of outer radius minus the square of quantity of inner radius dy. So if it is rotating in y-axis, the inner and the outer radius should be in terms of y. So we need to relabel y is equal to x squared into x is equal to the square root of y. Y is equal to the square root of x into x is equal to the y squared. So substitute all the values and take the constant out. We have now pi times the integration from 0 to 1. The outer radius is this 1 square root of y squared minus square root of the quantity of inner radius, this 1 y squared, and dy. Pi times the integral from 0 to 1. Square root of y times squared is y. Y squared times squared is y to the power 4 dy. Pi times the antiderivative of y is y squared over 2 minus the antiderivative of y to the power 4 is y to the power 5 over 5 from 0 to 1. So we have now pi times 1/2 minus 1/5. We have now pi times 3 over 10 or approximately 0.94 cubic unit. So using the washer method, the volume of the solid is 3 over 10 pi or approximately 0.94 cubic unit. So now let's try the shell method. So using the washer method, the volume is or approximately 0.94 cubic unit. So let's try the shell method. So if the cylindrical shell is rotating in y-axis, we will be using the formula V is equal to the integral from a to b 2 pi rh dx. Substitute all the values to the formula. We have now the integral from 0 to 1, 2 pi, the radius is x, and the height is x, square root of x minus x cubed dx. Take the constant out. We have now 2 pi times the integration from 0 to 1. X times square root of x is x to the power of 3 over 2 minus x cubed dx. 2 pi times the antiderivative. The antiderivative of x to the power of 3 over 2 is 2 over 5 times x to the power of 5 over 2 minus the antiderivative of x cubed is x to the power 4 over 4 from 0 to 1. So we have now 2 pi times 2 over 5 minus 1/4. So we have now 2 pi times 3 over 20 over 20. 3 over 20 is equal to 3 over 20 times 2 pi is equal to 3 over 10 pi, or approximately 0.94 cubic unit. So it concludes that whatever method you will use, you will get the same value of the volume. It depends on what you think is easier to use, or it also depends on the given problem.